My name is Josh Mayberry, and this is my color sorter. Let's take a look at the hardware in operation first. When powered, a DC motor rotates a disc at a slow speed. You place Lego pieces onto this disc, and they move past a camera which interprets the color of the piece. In this case, if the piece is red, the disc will continue to spin slowly for 2 seconds. It will then speed up for a second, flinging the red piece to the right of the user. The issue with using the disc is that the exact location where the pieces land is not exact. This is because before you place another piece onto the disc, you need to wait for it to slow down again. Here, I was impatient and used my hand to slow down the disc. As well, I did not wait for the disc to reach a steady state before placing a new piece onto it. This results in the pieces getting flinged to the general correct direction, but they do not hit the exact same spot every time. Blue pieces are flung ahead of the user. This is because the disc waits for 3 seconds before spinning up real quick. And yellow pieces are flung to the left of the user because the disc waits for 4 seconds before speeding up real quick. Now let's take a look at the software. The machine has 4 locations it can sort pieces into. To the right of the user is called bin 1, to the left is called bin 2, ahead is bin 3, and towards the user is bin 4. Upon startup, the machine asks the user how many of these bins they will be using. It then asks which color goes in each bin. When the user puts a color in a bin, it is removed from the list of available colors. In this case, we are using 3 bins. Once the color for each bin is set, the camera and motor turn on. 3 windows pop up. The first window displays a live feed from the camera. A picture is taken of the disc when the camera first turns on. The program then looks for differences in the current video frame and the first picture. Any differences are interpreted as motion. It does this by first converting the image into grayscale and then applying a Gaussian blur. The current frame is subtracted from the first frame, and any pixels over a threshold of 25 are made to look white, and any below 25 are made to look black. It then dilates the image to fill in any holes. The other 2 video frames show these differences. Those 2 frames are masked so that they focus on the bottom left of the frame. This is so that when they detect motion, the Lego is centered in the frame. I am realizing now that the disc was spinning in the wrong direction, so the Lego is not getting centered in this run. If the positive and negative leads to the motor had been switched, the pieces would be exactly in the center of the frame. It then searches for contours using a canny edge detector. If a contour has an area greater than 500 pixels, it is interpreted as a piece. In order to speed up computation time, the image is resized so the height is 300 pixels. It then looks at several RGB ranges. The number of pixels that fall into that range are then added up. If there are more than so many pixels in a specific range, then that color is determined to be the color of the Lego piece, and it is sorted accordingly. Thank you for your time.